In the lecture series on actuators in mechatronic systems, we are going to see about pneumatic and hydraulic actuators. First, we will start with the components of hydraulic and pneumatic actuator. So, this diagram represents a hydraulic or pneumatic system for controlling an actuator. The reservoir, it stores the compressed air or the fluid for which flows through the hand valve for manual control. The regulator, it adjusts the pressure before directing the air or fluid to the solenoid valve. It will regulate the pressure, and it operates electrically to control the airflow. The air then passes through the speed valve, which regulates the flow rate before reaching the actuator, which performs the desired mechanical action. So you have a returning path here, which allows the air to flow back to the reservoir, completing the cycle. This diagram represents a solenoid valve, an electromechanical device which is used to control the fluid or the gas flow. The coil, as labeled here, this coil, when it is energized, it generates a magnetic field. And you have the armature here. So this is the movable part that will respond to that generated magnetic field, lifting the stem lifting the stem to either open or close the control valve. And you have the spring here, which will return the armature to its default position whenever the coil is de-energized. So you also have the electrical connections, which provides to provide power to the coil, and the entire valve, it is has a housing which encases and protects the components, internal components. So when the solenoid is actuated, the coil magnetically lifts the armature, allowing the fluid or gas to pass through. When deactivated, the spring pushes the armature back and stopping the flow, right? So this is the example for a hydraulic actuator, wherein that is a JCB, which uses three hydraulic actuators in order to control the JCB arm. The air brake system in trains uses compressed air to control braking across all cars efficiently. So, compressor, it fills the main reservoir with the air, which is distributed through the train line, that is the brake pipe, and each car has an auxiliary reservoir and a triple valve, which will direct the air to the brake cylinder when the brakes are applied. So the brake cylinder pushes the brake block against the wheel, creating friction to slow the train. So when the brakes are released, the air is exhausted, allowing free movement. So this system ensures uniform braking, automatic emergency stops in case of pressure loss, and reliable operation across long distances. The key considerations in the actuator selection are tilt and pivot, lift and lower, position, roll and slide, open and close, tension. First, tilt and pivot. These terms relate the angular movement or the rotational capability of an actuator, and it emphasizes the range of motion required for a specific application. The next, lift and lower. This refers to the linear movement either up or down of an actuator, and it is important for applications involving vertical displacement. The next characteristic is position, roll and slide. So these terms describe the placement and movement of an actuator, whether it is stationary, rolling or sliding along a track or a surface. Then the next characteristic is open and close. This describes the basic cycling function of an actuator. Often it is used in applications like valves or switches. Then tension. This characteristic describes the force or the pressure that is exerted on an object, and it is important for adjusting the device and system. When selecting an actuator beyond the specific application, we need also to we should also consider certain other characteristics, that is the capacity, voltage, stroke length, speed, duty cycle, orientation, and also certain other special requirements. So the capacity, it is nothing but the force required. So the amount of force the actuator needs to generate to move the load or perform the required action is very important. And voltage, for electric actuators, the operating voltage is a crucial factor in order to ensure the compatibility with the power source. And for next is the stroke length. So this is the total distance the actuator can move, or the length of the shaft or the lead screw. Then speed, and the speed at which the actuator moves, especially when considering the weight and the force required, it is important for application performance. Then duty cycle. So this refers to the percentage of the time the actuator is in motion relative to the total time, indicating how often the actuator cycles between on and off. So next, orientation. So the relative position or direction in which the force is applied by the actuator is indicated by the orientation. And certain other special requirements includes factors like weather resistance, fire resistance, and leak prevention. So this is very critical depending on the application environment.